Venus is often called Earth's twin. It's almost the same size, similar mass, and made of the same rocky materials. If you looked at them from a distance, you'd think they were siblings born from the same cosmic nursery. But when you get closer, the resemblance ends. Venus is a nightmare. It's a world where the atmosphere is toxic, the temperature is hot enough to melt lead, and the surface pressure would crush you like a submarine in reverse. So, how did two such similar planets end up so radically different? What turned Venus into a hellish wasteland while Earth became a cradle of life? The answer lies in a story of runaway greenhouse effects, lost oceans, and a fate that could have been our own. Today, we're going to explore Venus, not as the evening star of myth, but as a cautionary tale, a warning of what happens when a planet's climate spirals out of control. Size, mass, and composition. Let's start with the similarities. Venus is about 95% the size of Earth and has about 81% of Earth's mass. Its density is nearly identical, which means its internal structure is similar: a metallic core, a rocky mantle, and a crust. When scientists look at the raw numbers, Venus is the closest match to Earth in the entire solar system. Both planets are also about the same age, formed around 4.5 billion years ago from the same solar nebula. In their early years, they might have looked alike. Both had oceans of molten rock. Both outgassed thick atmospheres. Both probably had water vapor and carbon dioxide. But then, something went wrong. While Earth's atmosphere evolved to become mostly nitrogen and oxygen, Venus's atmosphere became a blanket of carbon dioxide so thick that it triggered a catastrophe from which the planet never recovered. A blanket of poison. Venus's atmosphere is unlike anything in our solar system. It's composed of about 96.5% carbon dioxide and 3.5% nitrogen, with traces of sulfur dioxide, water vapor, and other gases. But the real shock is the pressure. At the surface, atmospheric pressure is 92 times that of Earth. That's equivalent to being nearly a kilometer underwater on Earth. The air itself is toxic. The sulfur dioxide combines with water vapor to create clouds of sulfuric acid that rain down but evaporate before reaching the surface. The upper cloud layers whip around the planet at speeds up to 360 kilometers per hour, creating a phenomenon called superrotation, where the atmosphere circles the planet in just 4 Earth days, much faster than Venus's own rotation. And then there's the greenhouse effect. Earth's greenhouse effect keeps our planet about 33 degrees Celsius warmer than it would otherwise be. Venus's greenhouse effect is so extreme that it raises the surface temperature by more than 500 degrees. The result is an average surface temperature of 464 degrees Celsius, or 867 degrees Fahrenheit. That's hot enough to melt lead, tin, and zinc. How Venus lost its oceans. So how did Venus get this way? The leading theory is that Venus experienced a runaway greenhouse effect early in its history. In the beginning, Venus likely had water, perhaps even oceans. But because Venus is closer to the Sun than Earth, it received more solar radiation. That extra energy caused water vapor to rise into the upper atmosphere. Water vapor is a potent greenhouse gas, so more water vapor meant more warming. More warming meant more evaporation. It was a positive feedback loop. Eventually, the upper atmosphere became so hot that water molecules were split by ultraviolet light from the sun. The hydrogen escaped into space, while the oxygen was locked into the rocks. The water was gone. Without water, carbon dioxide could no longer be drawn out of the atmosphere through weathering and carbonate formation. So, all the CO2 that had been outgassed from volcanoes stayed in the atmosphere, creating the thick, oppressive blanket we see today. In other words, Venus didn't just lose its atmosphere, it lost its ability to regulate itself. And it happened because it was just a little too close to the sun. A glimpse through the clouds. For centuries, Venus was shrouded in mystery. Its thick clouds made it impossible to see the surface with visible light. But in the 1970s and 1980s, radar mapping from spacecraft like NASA's Magellan pierced the veil. What they revealed was a world of volcanic plains, highland plateaus, and thousands of volcanic features. Unlike Earth, Venus has no plate tectonics. The surface appears to be a single stagnant lid, but it's geologically active. Scientists have identified fresh lava flows, and recent data from the European Space Agency's Venus Express mission found hotspots that suggest ongoing volcanism. Some of the lava domes and volcanic structures are so young that they may have erupted within the last few million years, or even today. The surface is dotted with strange features called pancake domes, formed by viscous lava, and tesserae, highly deformed mountainous regions that may be the remnants of ancient continents. There are impact craters, but surprisingly few. The surface appears to have been completely resurfaced by volcanism about 300 to 500 million years ago. Something, perhaps a massive mantle overturn, wiped the slate clean. A backward spin. Venus has another peculiarity. It spins backward. While most planets rotate in the same direction they orbit the Sun, Venus rotates in the opposite direction, a retrograde rotation. And it spins incredibly slowly. A single day on Venus lasts about 243 Earth days, which is actually longer than its year. One Venusian year is about 225 Earth days, so a day is longer than a year. Why does Venus spin backward? Some scientists think it's the result of a giant impact early in its history that tipped the planet over. Others suggest that tidal interactions with the Sun and the planet's thick atmosphere gradually slowed its rotation and eventually reversed it. Whatever the cause, this slow rotation contributes to the planet's lack of a global magnetic field. Without a magnetic field, Venus has no shield against the solar wind, which continues to strip away the upper atmosphere, though the thick lower atmosphere remains unaffected. Clues in the atmosphere. One of the biggest questions about Venus is whether it ever had oceans. The evidence is indirect but compelling. Scientists measure the ratio of deuterium to hydrogen in Venus's atmosphere. Deuterium is a heavier isotope of hydrogen. Venus has an extremely high deuterium to hydrogen ratio compared to Earth, which suggests that large amounts of hydrogen, the main component of water, have escaped into space over time. The only way to lose so much hydrogen is if Venus once had a substantial amount of water. Estimates vary, but some models suggest Venus could have had a global ocean tens of meters deep, or even hundreds of meters, for perhaps 1 billion years. That's enough time for life to potentially emerge. But the ocean would have gradually evaporated as the sun brightened and the greenhouse feedback kicked in. Today, the only water left is in the form of trace amounts of water vapor in the atmosphere and possibly in the clouds. If Venus did have oceans, then the question becomes, could life have existed there? And if it did, does anything survive today? Perhaps in the clouds, where temperatures and pressures are more Earth-like? Clouds of possibility. In recent years, Venus has made a comeback as a potential abode for life, not on the surface, but in the clouds. About 50 kilometers above the surface, the pressure and temperature are surprisingly Earth-like. Roughly 0.5 to 1 bar of pressure and temperatures between 0 and 50 degrees Celsius. The clouds contain droplets of sulfuric acid, but also unknown dark patches that absorb ultraviolet light. In 2020, scientists announced the tentative detection of phosphine, a gas that on Earth is produced by microbes, in Venus's clouds. The detection was controversial and later disputed, but it reignited interest in Venus as a potential habitat. Could there be microbial life floating in the temperate layers of the atmosphere, adapted to extreme acidity? It's a long shot, but not impossible. Several missions are now headed to Venus to find out. NASA's Da Vinci mission will drop a probe through the atmosphere, measuring gases and looking for signs of past or present life. Veritas will map the surface in high resolution, and the European Space Agency's Envision will study the planet's geology and atmosphere. For the first time in decades, Venus is once again a priority. A warning from the past. Venus is often called Earth's evil twin, but perhaps it's more accurate to call it Earth's cautionary twin. It shows us what can happen when a planet's climate feedbacks run away when water is lost, and when the greenhouse effect spirals out of control. We are currently pumping carbon dioxide into our own atmosphere at an unprecedented rate. Earth is not Venus. We are farther from the sun, we have plate tectonics, and we have life that helps regulate carbon. But the lesson is clear. Planets can tip into a state from which they never recover. Studying Venus is not just about understanding a neighbor, it's about understanding our own future. It's about learning how planets evolve, how they become habitable or uninhabitable, and how we might protect our own world. Venus may be a hell today, but it holds the keys to some of the most important questions we can ask. What do you think? Could life have existed on ancient Venus? And what does Venus's fate tell us about our own planet? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.